Hi, welcome to my channel, The Machine Learning Engineer. Today we cover another video on the series Agentic AI, and we are gonna continue with showing some other features of the Google ADK, the Google Agent Development Kit. And today we will showcase other features available on the development kit. We are going to check how to connect an agent, a chatbot agent, with OpenAPI tools, how to create OpenAPI tools, and also how to well, I don't see it very well, how to do observability, how to use the observability capabilities of the toolkit. And in this case we will log all the activity and traces of our interaction with the bot to weight and biases. My name is Juan. I'm an assistant engineer with more than 30 years of experience on the IT sector, and the last 10 years dedicated to the AI and ML space. Okay, for those are familiar with my YouTube channel, this is the third video I'm doing on this series. The fourth, to be precise. We cover how to create tools and expose them via NCP servers, how to connect these tools exposed via NCP servers and connect them to ChatGPT using either the conventional chat, so create a custom connector which a custom connector to an NCP server, which in our case is exposing a Microsoft SQL Server database. We also do another video where we define we create a NCP server with which is compatible with custom tools for subscriptions in Cloud AI. And the third video we did is create a server using with a OpenAPI interface, which expose the same tools that we create for the two NCP servers, one compatible with ChatGPT and the other one with Claude. We do the same, but in that case just using instead to use the NCP protocol, use the OpenAPI version 3.0 and connect in that case GPTs, custom GPTs in a ChatGPT subscription, and we create some tools connected to our custom GPT, and in this case we had to use an OpenAPI RESTful interface. So these three previous videos we define all the infrastructure. This infrastructure is a multi-tenant infrastructure deployed on a Docker Compose project, deployed with in the front with an nginx reverse proxy, which is acting as a ending tunneling ending tunnels, SSL tunnels. So we end the SSL encryption that is necessary to implement from to establish the connection from the Cloud AI or ChatGPT infrastructure. There is a tunnel which ends in our reverse proxy, nginx reverse proxy, and then on we use as well this reverse proxy. The encryption is done with a certificate which is provided by Let's Encrypt. Let's Encrypt, for those that are not familiar, is a certification authority, which is a well-known certification authority which provides services for more, as you can see here on their website, to more than 700 million of websites. Well known, is free, you just need to request it. By default, these certificates are valid for 90 days, and then on every 90 days by default you can extend it or reduce this deadline. You can renew for free as well the certificate. We as well deployed Therbot. Therbot as well is a bot which the only function it has is check every 12 hours that the certificate is still valid and is renewing the certificate automatically. And then on we have as well as I said, some Docker containers which essentially implement the whole multi-tenant infrastructure with multiple NCP servers, and all of them are exposed through the same public public IP address. Remember to in this infrastructure, if you didn't see the 3 previous videos where I explain all the architecture, I recommend you to see them, where I explain how is all the whole infrastructure, how to set up the NCP servers, how to connect from Cloud, how to connect from ChatGPT or NCP connectors, or how to connect from custom GPTs. in those videos I explain all the infrastructure, how to set up the reverse proxy, how to set up the Therbot, how to set up the different NCP servers, the functionality, and so on and so forth. Today we are going to use directly the OpenAPI. We are not going to cover this anymore. If you are interested and you cannot find it, let me know on the messages of the video, and I will point you out to the right video in order you to understand how any of these servers that you see, any of these containers are configured. Those 2 are commons for the whole infrastructure, and then there is a video for NCP server compatible with ChatGPT, NCP server compatible with Cloud, and NCP server compatible with custom GPT using OpenAPI. Today we are going to connect our ADK to the OpenAPI action server, and then we will be using the connection in a chatbot, and then we will be interacting with an LLM. In this case, it's going to be OpenAI model. It can be any, because as you probably remember, ADK is model agnostic and also deployment agnostic. It's designed to work more efficiently, obviously, with Google models, but it's a framework which essentially allows us to work with any model, either commercial or non-commercial model. And then on any of these servers give us access to an SQL database. This SQL database is configured with some security features in order to avoid that somebody can modify. Where we are doing SQL sanitization, we are doing many things, but all this stuff is already explained in these 3 previous videos. Today we are going to focus only on the use of ADK with an OpenAPI custom server which is already deployed and running. Remember as well that for any of these connections you need to have a public IP address with in a domain which is also public, and also you have to have a DNS entry for that public IP address, and this you need to have a certificate issued by a recognized certification authority for end days. In this case, as I mentioned you before, we are using Let's Encrypt. Okay, everything running in containers, in Docker containers, and the whole project is running in Docker Compose, and we are deploying this into a VM, but it can be done in Kubernetes, can be done in container services. Currently, for simplicity, I have deployed this in a virtual machine in Google, but yeah, this is just for this POC I'm doing for the whole project, which in my case is connecting different subscriptions, different agent technologies to the private data of a company. Just leave it like that. Okay, So this is a brief of the architecture of the we are going to connect. In this case, we are going to connect to this OpenAPI server, which is exposed via a RESTful API implemented in OpenAPI 3.1, and which is exposed to internet via a public IP address which is managed by our NGINS reverse proxy. Okay, having said that, let's move a little bit what we have here. So we are gonna do this with the agent development kit. The agent development kit, as you probably remember, is a framework for developing and deploying agents, deploying AI agents. As I mentioned, it's optimized for Google ecosystem, but ADK is model agnostic and deployment agnostic, and is built for compatibility with other frameworks. It's designed for developers to developers, if you want to say this. It's really Pythonic, and has a lot of possibility. Today we will see how to, in previous videos we make an introduction how to use the development kit. We did another video where we explore the multi-agent functionality, and in this video we are going to explore other functionality. In this case, the tools connected. Instead, in the multi-agents video, we connect the agents to a NCP server. In this case, we are going to connect the agent to a OpenAPI server. There is different components in the framework. Some of them are for connections to NCP servers, some others for connections to OpenAPI servers. In this case, we will use the OpenAPI toolset, which is a library that comes with the toolkit, and the library essentially comes with the ADK and simplify the interacting with the external REST API. We need the schema which we have implemented in our NCP in our OpenAPI server. Here, essentially, when you create an OpenAPI server, you are creating a RESTful API. You are probably very familiar with that. We use it in many places with Fast API, with Flags, for example, as well. We create this in combination with the Pydantic library, and we create some entry points with finally our servers for either Ubicon or other technology. And essentially, this is that data contract to exchange information in and out with a server. Here, this finally creates what we know as a schema of our first of all, of the entry points that we had, or the routes in your application server, and secondly, the data schema or the data that you expect to receive in each entry point or route, and secondly, the data schema or the data class or the data map or the data that that entry point is going to return to the server. And then, in that case, OpenAPI toolset, what it's doing is taking the schema of our OpenAPI server and convert it into tools. So it had two main classes. One is the OpenAPI toolset class, and the other one is the REST API tool. The REST API tool is an object which represents a tool itself, is converting a route in your application server into a tool which is able to be binded or connected or linked to an agent and and the model will be able to use it. We will do the authentication in this case with an HTTP bearer token. If there is three possibilities to connect in the ADK. One is no authentication, which I honestly don't recommend you, especially if you are connecting this with your private data. It's up to you, but I don't recommend you. Then there is a HTTP bearer, which is a header, authentication header with a key, which just you have to share with your users. And also it's possible to use OAuth. For simplicity, I use an HTTP bearer header, but I also strongly recommend you to move to OAuth because it's more robust and you don't need to exchange passwords in between users that need to use the OpenAPI toolset server. Sorry. But well, for simplicity, I did that. In a next video, I plan to do with other tool servers that I had done, Neo4j or one I had done for finance. I plan to do it with OAuth, but for the time being, we are going to use in this video HTTP bearer token to authenticate all the requests, get and post that we will use to interact from our agent in command. We are gonna go for command line in this case with our OpenAPI server. We will need to have this token and every every request that we do get or post need to be authenticated in order to be served or be triggered by our agent. So it's not only that we will discover the tools that are able to be used, also we need to send the token every time that we make a request, post or get to the server. So the tools discovery here in the toolset is done manually. It's just loading the schema, and the API OpenAPI toolset is going to convert this in local this schema representation into the different tools that we had available. So you take a look to the model. So if we point to our server, you put actions, and you just write the URL to your OpenAPI server. You write in this case is being served in /domain/actions, and then you write OpenAPI.json. You receive the schema of your RESTful API. This is a OpenAPI 3.1.0. This is a read-only NCP server for SQL, and then on you are this is explained in the previous videos. We are doing some sanitization of SQL in order to avoid that anybody modifying the database. Is a read-only database, and then we had 4 tools: list tables, describe tables, execute SQL. You can see here as well that every entry here on the schema had as well the parameters they need to work. Here table name, etc. etc. Execute SQL, get table sample, and here we have the components, the schemas. This is the schemas in and out, so what every entry is expecting to receive as data, the input, and what the model response. Describe table response, a describe table, where is this? Components, describe column, exactly. This describe tablet response, which is using row count, total columns, etc. So we have an schema, and here you have the column, which is an object described column. So every entry point is converted into a tool, and you need to, or the model is specifying the data model for input and the data model for output. Everything is coming in your OpenAPI.json, and this is the file that we need to provide to the OpenAPI toolkit in order to the toolkit create the tools that later is gonna bind to the agent in local. You had all this stuff described in here in this JSON file, and then on you had some metadata which start here in security schemas, which is the authentication that is gonna be used in for this server. In this case, as you can see here, we had a header and HTTP header, and this is the authentication schema or mode that we are gonna use for this server. This is the URL where we are exposing the server. So let's move to the code. You have this schema, you need to download it, as you can see here, and then to later on provide it to the to your code. No? And then let's take a look to the code. This is exactly the same that what I showed you. That is, you just point with a get to this URL on the server, and you get this JSON, and then you just save it, and you make it available to to your script, the script which is gonna run the agent. So here in the script, this script is the one that is creating the chatbot. Let's take a look first of all to a little bit to the architecture. So the chatbot will run it in by command line. The runner is the one who is this is the equivalent to inline chain, for example, to do invoke or to run a session with your agent. And then on here, we load the schema and create the tools, and we bind it to the agent. In the other side, in parallel, we are also creating a chat loop, which essentially is a loop, is a while, infinity while, up to you write exit or end. And this we are creating our agent with LiteLLM. We are connected to GPT 4.0, and we create an instruction which essentially instruct the model how to use the tools and how to use it. This loop, you will be interacting with the model. You can ask topics related to the data that we have in our database, or you can ask general questions. Is how usually a chatbot is working. The requests essentially are send it to the interface, which we have it in this domain, and the SQL server is validating the SQL. This is the SQL sanitization and response with a JSON object that later we serialize. All this is as well connected with is optional, but by default, if you don't say anything, it's gonna try to log everything in weight and biases. Weight and biases is a platform, observability platform, very well known. There is multiple options to do login, and let me remember, and monitoring. Let me remember where I have that. 1 second. Oh, it has so many things open as usual. Exactly. Let me. We have possibility to do logging, conventional logging with a logging facilities, CloudTrace, agents of OPS, which is a collaboration with a third party, Google, and third party, Aris AX, Phoenix, and weight and bias whip. Weight and bias whip is the one that we are going to use today. And then later at the end of the demo, we will see how this essentially log of the activity of our agent and the bot that we are creating here. So we import all the libraries that we need, fast API for the builder, the agents, credentials, LiteLLM, the runner to run the session of this agentic AI bot. Memory too, obviously, if we are interacting with a model, we need to provide some memory for the session. As you well know that the models, if you doesn't remember what you asked before, if you don't create some memory to save the interaction that you had previously. Then if you don't do that, the model is not going to have the context of the previous interaction that you had with it. So we have here some definitions, some helpers. We here read the OpenAPI specification, so we read the schema. We build the toolset. We are receiving the specification in a string format, and we create a OpenAPI toolset object with bearer authentication. You can see here we create a bearer, an authentication credential, and we return an object OpenAPI toolset. Here we are creating the tracing connected to 1DB, weight and biases. We use OpenTelemetry, which is also a very well-known library for logging telemetry in multiple technologies. And we essentially, in this case, decide to log into weight and bias, and later on we will look at that. Here we are building the agent. The agent is using LiteLLM. The model name is the constant that we have there with a temperature, and the model essentially is the LLM together with the name, description, and instruction, and the toolset. The toolset is what we receive here as a parameter. Later on we will look at here how it works. Here we define the chat loop, define the memory for the session. We create the session with an app name, a user ID. This is some of the constants that we have here on the top. And where are you? Here, and the session ID, no state, obviously, because there is no state at when we just create. And then with the session, we just create the runner. And once we have the runner with our agent, with our application, with a service, we just enter in a loop where we just simply we are reading the input of the command line, and we are interacting with the model. Once you get after you don't write a sheet of code, you are interacting with the model. And then on here we are just creating content, and once you write something on the command line, we run asynchronously the model using the functions essentially. Pretty simple. Obviously this is not a production ready application, it's just a demo. Here we have the parse arguments, and here we are defining the main. We get the OpenAPI key, the token to connect to the OpenAPI server, and then we configure the tracing, we read the specification file, we build the OpenAPI toolset, and we build the agent. And once we build the agent, we run a chat loop, which is this method, asynchronously up to we write exit or quit or exit exactly. And yeah, and depending on how we write, verbose or no verbose, it will be more logging or less logging. And then after we can also press Ctrl C, but yeah, this will be close the loop if we press a Ctrl C. Okay, so let's do a short demo of this. Let me CLS Okay, so now we are going to just simply execute the model. And then before we start, let me show you a little bit ADK. So, weight and bias. This is the dashboard. Here we just create a project. Take a look to the documentation. I will recommend you. There is a very extensive and good documentation of the weight and biases, so you can take a look there and see how it works. We are not going to enter. This is a topic to cover more than 1 hour of video. Here I'm going just to say you this. You are familiar with with LangSmith or LangFuse or other observability platform. This is pretty similar. You see here every invocation. This is something I ran some minutes ago. I remember 1 hour ago I make an invocation. Here we just run the agent, we call this LLM, we execute list tables, and then on some objects. We will not enter too much. I just wanted to show you that it's possible to integrate with these platforms, and then later I will point you out to the documentation, and you can decide which tool is the best that satisfies the needs of the requirements of your project. So here, let's do a list all tables in the database, and then we'll see what's going on here. As you can see here, calls list table, the server already returned the tables to the agent, and now the agent is preparing the answer. So different schemas, we had 4 different schemas, and then now describe, for example, table, this one, now it's going to invoke other tool, and you can see here describe table is invoking the tool discrete table discrete table get is one of the this is the tool that the toolkit had created for that entry point, and here we have the description of that table. Now get me aggregated data of that table by, for example, batch type. Now we are gonna here you can see the query. Now here execute SQL query, SQL batch type count as count blah 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 group by batch type, the table that we check, and now the tool already requested, and you can see here the aggregate data grouped by batch ID. Let's do the same by show red, for example, and you can see here the different shows. Now we can do exit. Interesting why in some cases, well, the login here we can improve it better, but well, it doesn't really matter. Now we can check here in weight and biases. So the 4 invocations that we did, you can see here the execution of list tables, the first that we did. Here we have describe table, and here we had SQL posts. So SQL is done by post, the other are done by get. and here the second SQL post. These are the two aggregations I did some moments ago. So here you can you can have here different options that you can even do your own nodes. And well, the platform, if you are familiar with Smith, is pretty similar, and then you can create multiple projects for multiple AI. You have a lot of functionality here that you can explore. It's up to you. We are not going to cover this today again because it's not the matter of the video. I just wanted to show you that it's possible to use these monitoring platforms, and one of them, probably the most of the one which is used by ADK, which is more known across the industries, weight and biases, and that's why I wanted to how to say show you that is how to do it. You have the code, you can take a look, you can explore user weight and biases. Again, they have a very good documentation. If you are familiar as well with MLflow, with this is kind of an equivalent of MLflow, but it's a fully SaaS platform, and then on is capturing all the activity or your training, fine tuning, or traces like here. They are expanding the functionalities every month. You have more and more functionality, and today is probably one of the key players on that on this matter on observability and logging and reporting, many things that you can do with the platform. I strongly recommend you take a look. If you prefer other. For the time being, as I said, it's not integrated with LangSmith or LangFuse. Probably there is ways to do it, but natively and in the documentation today, 31 of October 2025, is not integrated yet with those platforms. Integrated, as I mentioned you, with weight and biases and other platforms that you have in the documentation. Later on, I will send you as well the documentation, and you can review some links of the key documentations, and you can review exactly what I'm talking about. And that's pretty much all. Thank you very much for watching the video up to this point. I hope that you find it interesting, useful, and what is that? Here I have this, yeah, interesting, useful. And if so, subscribe to the channel. If you are not already subscribed, give me a like. I recommend you to become member of the channel. This way you have access to projects. It's part of all the material I had on the channel. In the channel there is around about 900 different videos about all the aspects we had in AI, but many of the stuff is focusing in generative AI and agentic AI. Plenty of the material is free of access, but only these complex projects with I'm explaining these more state-of-the-art topics and complex projects end-to-end, I just reserve them for obviously for members of the channel, paid members of the channel. It's anyway you can see the video, you can get an idea. I provide the documentation in the description of the video. You can always get access to most of the content. The content is free to use, free to see, but the code and the notebooks and all the materials just to you replicate exactly what you saw in the video is only available for some of the projects. We had already 35 projects end to end on the channel. As I said, it's only for paid members. Also, you can help me to continue with this project. Just sharing this content with friends and colleagues, and also making comments, and this way, well, you know, the algorithm put me up on the channel on YouTube, and more people is able to access to my content. Thank you very much, and see you in the next video.